going to be looking at the law of sines in this particular lecture, and the law of sines is used to solve oblique triangles. Now, oblique triangles basically means any triangle without a 90-degree angle. Now, there's a couple different ways that we can do this. We can work with law of sines, or we can work with laws of cosines. This lecture is going to be focusing on the law of sines. So there's a couple different things that we need to be aware of. First of all, we talked about what an oblique triangle is, and it does not have a right angle. So be careful when you're drawing these that you don't include a right angle, and you can't assume a right angle either. Now, we can solve a triangle, which means finding all three sides and all three angles, if we know at least one side and any other two measures are known. Okay, so that could be another side or another angle. So we have three different scenarios for solving oblique triangles. The first one we want to look at is called side angle angle. And the second one we want to look at along these same lines is angle side angle. So if you notice, these are both one side and two angles. Well, let's go ahead and look at side angle angle first. I'll make a little bit extra room here. So side angle angle. And again, there's no 90-degree angle here, so you're not going to see a little square in the corner. So this is if I know, let's say, a side and then two angles. So again, side, angle, angle. Now another case here is angle side angle. So I could have an angle, a side, and an angle. So this is angle side angle. The other case that we can look at would be side side angle. Now this one's different because I know two sides and one angle. So this would be a setup where I might have something like side, side, angle. Now of course this could be two different sides and another angle, but just notice that it's not the included angle in between the two sides. That makes a difference. So these scenarios I can solve using law of sines. And you can go through and look at the development of law of sines in your ebook if you'd like to, or if you want to let me know, I could meet with you online and we could go through that as well. So I'm not going to prove law of sines, but what I want to do is be able to use law of sines. So to be able to use law of sines, first of all, you have to have some sort of a triangle. And again, it's an oblique triangle. That means it does not have a 90-degree angle. And so for this one, I'll call my angles A, B, and C. And that would mean the side opposite of angle A is side A, the side opposite angle B is side B, and the side opposite angle C is side C. So the law of sines can be written in one of two forms, and it doesn't matter which one you use. Sometimes one is handier than the other, but basically it means it's the ratio of side A to the sine of the opposite angle, sine A. And this is equal to the proportion of the other sides to their opposite angles as well. Now when we're using law of sines, it doesn't matter if we set it up like this or if we put the sine of the angle on top and all of the sides opposite on the bottom. So sometimes it's easier to choose one over the other, but either one will work. Now a couple things I want you to keep in mind here. Lowercase a, b, and c are sides. Capital A, B, C are angles. Now we don't usually use all three of these pieces. We usually use like these first two or these second two, or we might use sine A and sine C. So we don't use all three. What we do is we pick two out of the three parts, set up the proportion, cross, multiply, and divide. So you definitely want to have the law of sines on a note card. You're going to be using it often. Now there's two other cases we haven't looked at, and that would be side angle side and side side side, and those would be solved using the law of cosine. So we'll get to that in the next video. Now if we know three angles of a triangle, like angle, 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 we can't find a unique side length because we need to know at least one side in order to solve a congruent triangle. So that's something to keep in mind. Now there's one other note here, one other formula we're going to want to have, and even though we're not going to use it quite yet, we'll use it a little bit later on in the video, I want to make sure that we get it put right up front so that way you can get it put on your note card as well. This would be the area of a triangle. Well, you might say, well, I know the area of a triangle. The area of a triangle is 1/2 base times height. Well, sometimes finding the base or the height is really difficult based on the information that's provided. So there's three different area of a triangle formulas that we can use here. It's A equals 1/2 BC, and this is side BC, and this is going to be sine A. So instead of writing an A here, I'm going to write area, because I don't want the letter A to be confused with the angle A. So the area of a triangle is 1/2 side B times side C times the sine of angle A. Okay, I can also rewrite this as 1/2 AB sine C. Okay, and we can look at another one as well. Our last one here would be the area is 1/2 AC sine B. So these are basically, if you look at this, I have sides A and C and then the angle B. So AC and B are represented in all these in some way. Now again, make sure these are on a note card and you can refer to them often. Well, what I'm really saying here then is that the area is half the product of the length. So this would be length of two sides. And it doesn't matter here which two sides. And I have to have the sine of the angle included between them. So if we look at a quick picture here, we could look at a triangle similar to what we drew up above. So we'd have angle A, angle B, angle C, side A, side B, side C. And let's go ahead and look at this first one right here. So I would know B and C. So B and C would be known. So I'm going to put those in red. And then sine A would be this angle that's between them. So it's these two sides make up that particular angle. So I think these are the formulas that you'll want to know for this particular section. And I think the best thing to do now is to go ahead and start working through quite a few different problems. Okay, so for our first one, and there's a lot of different ways that we can set these up. And I'll show you a couple of ideas on how you might see these in my math lab and how you might see them also in your handwritten homework. So let's go ahead and pull this one in. Now make sure you read the directions carefully. They might ask you to round to the nearest tenth. They might ask you to round to the nearest hundredth. They might want an exact answer. So make sure again that you're reading these carefully. We're going to definitely need a calculator here. And again, with your calculator, make sure that you're in either degree mode or radian mode. So for this problem, certainly we'll be in degree mode. Okay, so to get started, I kind of want to organize this. For a triangle, I have sides and I have angles. So for my sides, that would be the lowercase a, b, and c. And for my angles, that would be capital A, capital B, capital C. So for this problem, I'm given that c equals 4 miles. I guess I really won't even worry about the units here in my table that I'm summarizing. And for b, I have, sorry, this should be lowercase c. I need to make a distinction here. This is an angle C. This would be 32.48 degrees. Side C is 4 miles. Angle B is 37.56 degrees. So what situation do we have here? Do we have angle, side, angle? Do we have side, side, side? You know, we need to look at those different cases and see which one we have here. Now remember, for the law of sines, I can only use side, angle, angle, or angle, side, angle. And I definitely see that we have two angles and a side here, so this might work nice. Now before I get started, I'm going to give you a hint on how I know I'm using law of sines. I'll also let you know that when we're working this problem, again, it's oblique, there's no right angles. Okay? And then what I can look at is I can look to see the key behind law of sines is that you know at least one side and its opposite angle. That's kind of the big important thing. So if we go ahead and label A, B, C for my angles, and then I have side A, side B, and side C, I can kind of fill in what I know here. So I know B is 37.56 degrees. I know that C is 32.48 degrees. Okay, now I know side C is 4. So what I need to know is basically everything else. Well, if you notice right here, I know an angle and its opposite side. And if I know an angle and its opposite side, that really sets up a nice situation for law of sines. Now if I had to look at what was given to me here, it looks like I'm given angle, angle, side. Or if we want to think about it in the clockwise direction, side, angle, angle. Now it's not really important that we memorize angle, side, angle, angle, all that. What I would always do is sketch the triangle, fill in what you know, label what you don't know, and then see if you have this set up of one angle and its side opposite. So again, this is side, angle, angle. But again, not crucial to be able to state that. What we want to be able to do is to solve this. So this value for C is going to kind of be the key to solving this. Now the law of sines would be the sine of angle C over the side C. And then I could figure out whether I want to work with A or if I want to work with B here. I can't work with A right now because I don't know the angle A and I don't know the side A. So I better go ahead and work with B. Now I could figure out A pretty easily by knowing that the sum of the angles of a triangle add up to 180 degrees. Good. I'm just going to go ahead and find side B. So let's go ahead and label what I'm up to here. I'm going to find side B. And so I will use the sine of B over lowercase b. So that's what I'm going to use for my setup. I don't need the sine of A over side A. I don't want all three parts. I just want two of the parts that I can use. So sine of C, that's a sine of 32.48 degrees over the side of C, which is 4, is equal to the sine of B, which is 37.56 degrees. And this is my unknown then, is the side B. Well, the way I'll solve this is I'll cross multiply. So I'll end up with B sine 32.48 degrees equals 4 sine 37.56 degrees. Of course, to solve for B, then I divide both sides through by the sine of 32.48 degrees. And whatever you do to one side, you do to the other, so we're just using some algebra here. So on the left, what happens is I have canceling occurring, and then I'll be left with B is equal to 4 sine 37.56 degrees over the sine of 32.48 degrees. Now in our original problem, it doesn't look like there's any instructions right now in terms of rounding. Let's go ahead and just kind of make up our own rule right now. Let's go ahead and go to one decimal place if we need to. So what we'll do is we'll plug this into the calculator, and again, you're not going to be able to solve most of these without a calculator unless they're standard angles. So let's go ahead and put in, and if you want to use your fraction key, you can. 4 sine, whoops, I already have a mistake. Look up here, I'm in radians. So let's clear. Let's go to my mode. Let's go ahead and go down here and set up to degrees. Okay. Now that I'm in degrees up here, let's go ahead and put this in. So I'll have 4 sine 37.56 degrees. And I'm in degree mode, so that'll work great. Divided by sine 32.48 degrees. Hit enter, and there's my value, 4.54067, etc. So let's go ahead and pop this into our lecture so we can have that value. So this is equal to 4.540677963, and let's go ahead and round this to the nearest tenth. This would be 4.5. So I get B equals 4.5. So let's go ahead and come up here and fill that in. So B equals 4.5. Now 4.5 is a rounded value. So you have to be careful, because if I use this rounded value in my next calculation, it's going to start throwing it off by decimal places. So what you need to remember is you always want to work with givens. So given are the numbers I should always try and work with, because I know they're correct because they were given to me. I don't want to necessarily work with this 4.5 because I could have made a mistake, and if I use it in my next calculation I might create more mistakes. Okay, so something to keep in mind. Let's go ahead and find angle A next. And again, I could have found that first if you wanted, but it doesn't end up mattering for this problem. So angle A. So angle A plus 37.56 degrees plus 32.48 degrees has to equal 180 degrees. So if I add these two together and subtract from 180, I get angle A equals, let's go ahead and pop the calculator open. So I'll have 180 minus 37.56 minus, I want to make sure I have a minus there, 32.48. So that's 109.96, 109.96. So angle A is 109.96. So let's go ahead and come up and put that in here. That's 109.96 degrees. Now right away I want you to notice something. The 109 should have been down here where angle C is because it looks bigger, but we don't want to get caught up in proportion for these angles. So the angle of the triangle is just basically used best for reference. Okay, it's not going to be used for you to like get out a tool and measure it. So here I will have 109.96. And again, always read your rounding instructions. And I guess we could fill in B now is 4.5. So I have that one as well. So next I need to find side A. Now to find side A, I'm going to have to go ahead and set up my law of sines again, but I don't want to go off of anything from B because I could have a mistake here, so I still want to go off of C. So let's go ahead and look at finding side A. So again, side A would be the sine of C over side C equals the sine of angle A over side A. And I want to solve for side A, so this will work great. Now again, I don't want to use B because I could have made a mistake when I was calculating there. So sine C would be the sine of 32.48 degrees over side C, which is 4, is equal to the sine of angle A, and I just figured out what that was. It's 109.96 degrees over the side A. And again, that's what we're looking for. You have a nice proportion set up, so you go ahead and cross multiply. So I'll have A sine 32.48 degrees equals 4 sine 109.96 degrees. Again, you want to solve for A, so we cross multiply and then we divide both sides by the sine of 32.48 degrees. Okay, these cancel, and I'm left with A equals 4 sine 109.96 degrees over the sine of 32.48 degrees. So let's go ahead and grab our calculator and we'll put that in and get our exact, I guess it's not really exact, we'll get our decimal value, and then from there we'll go ahead and round it, let's say to the nearest tenth. So I have 4 sine, and if you want to use your fraction key you could do alpha y equal. So 4 sine 109.96, and again sorry, I'm using my fingers here on the keyboard, and maybe I shouldn't. I'll just use my mouse because I seem to be hitting more than one key at once. 109.96 degrees, and I am in degree mode, and the denominator would be the sine of 32.48 degrees. 32.48. Okay, there's my decimal. So we'll copy that into the lecture, and then we'll round accordingly. So this is equal to 7.001281984 to the nearest tenth. So if we round this to the nearest tenth, then this would round to side A is equal to 7.0. So that's solving a triangle. That's finding all those missing sides. And then this table kind of helps me summarize that. Okay, so again, the given is then that orange highlighted that was provided to me for the problem, and then I kind of worked from there. Now the clue that I should use law of sines is I knew an angle and its opposite side. So that's always a good hint and a spot to get started. So for this next problem, it says find the length of side A. So they're not asking us to find everything, they just want us to find side A. And it says do not use a calculator. So that means that we should be able to find something at about these using exact angles. Now this situation that I have here shows me an angle, a side, and an angle. So this is angle, side, angle, which is a law of sines. And we only know law of sines right now. But pretty soon the law of sines and cosines will be mixed together. So that will be important to be able to distinguish these. Now before I can use law of sines, I need to know one angle at least and an opposite side. And I don't have that here. However, I could get it if I could figure out what side C was, or sorry, angle C was to go with the side C that I know. So let's go ahead and start with angle C here. Angle C is going to equal to 180 degrees minus 60 degrees minus 75 degrees. So 180 minus 60 would be 120. 120 minus 75 is going to equal 45 degrees. So this is 45 degrees. Now I know an angle and its opposite side. So let's go ahead and set up law of sines. Remember, I want to find A. So I want to use sine of 60 in the side of A. So this would be the sine of 45 degrees over 2 root 2 is equal to the sine of 60 degrees over A. So if you wanted to look at which one we're using here, we're using the sine of C over side C equals the sine of A over the side of A. And as usual, we might think about cross multiplying, except we know what the sine of 45 is and we know what the sine of 60 is. So I'm going to go ahead and cross multiply first, and then I will plug in for these exact values, because again the instructions were do not use a calculator, find exact values. So if I cross multiply, I have a sine of 45 degrees is equal to 2 root 2 sine of 60 degrees. And after you cross multiply, you need to divide by the sine of 45 degrees. And then I'll start plugging in for what I know here. And again, canceling occurs, and I'm left with A equals 2 root 2. The sine of 60 degrees is square root of 3 over 2. And the sine of 45 degrees is the square root of 2 over 2. So we kind of have a lot of fractions here, so let's go ahead and rewrite. This would be 2 root 2, I'm going to say over 1, times the square root of 3 over 2. So that's that entire numerator. Now I'm going to divide by the fraction root 2 over 2, which means to multiply by the reciprocal. So this is times 2 over root 2. So let's see what it will cancel here. It looks like the 2's could cancel here. Root 2's will cancel top to bottom, and I will be left with 2 root 3. So in this case, I get A equals 2 square roots of 3. And that's all they wanted here, side A. They didn't ask us to find or solve for the entire triangle. So in this case, 2 root 3 is an exact answer. So again, an exact answer usually means there's a radical involved. Let's go ahead and look at an application type problem next. Now some of this will be a little bit of a review when we were starting to talk about in previous units where we were looking at like sailing degrees north, northeast, that type of thing. So let's go ahead and draw a picture here first. It'll be a little bit easier to work with. So we have a ship, and the ship is sailing due north. So we'll say it's starting here and it's sailing due north. So it's heading straight north. It says at a certain point the bearing of a lighthouse that is 5.1 kilometers away is north 39.9 degrees east. So the way we could look at that is here's north, here's east, kind of in this direction. So my bearing to this lighthouse that's 5.1 kilometers away is north 39.99 degrees east. Okay, because this is east. Now it says later on, and again we're sailing straight north, later on the captain notices that the bearing of the lighthouse has become south, so that means we must be past it because now we're going to move south, east, 31.4 degrees. And it says, how far did the ship travel between the two observations of the lighthouse? So I'm this dot and this dot starting in the end point, I'm going to call side C. This would then be angle C, and I could call these other ones, let's say A, B, and side B. So it doesn't matter which is A, B, and C, it matters that we always have an angle on the side opposite. So to get started, we are looking for the distance from our start to our end point. So this is what we have right here. Now I also have B and side B, so I know an angle and its opposite side, so I can use law of sines here. And I also have angle, angle, side if we want to think about it like that. So again, angle, angle, side, you don't have to have all of these memorized, but angle, angle, side, or side, angle, angle if you want to look at it clockwise, is a law of sines problem. Okay, so if we have the law of sines, I'm using B and C. A, I really don't need to know right now. It's not going to come into play here. I just have it labeled so far. So let's go ahead and set this up. This would be the sine of 31.4 degrees. Actually, let's go ahead and put in the A, B's, and C's first. The sine of B over the side of B is going to be equal to, and again I'm wanting to solve for C here, the sine of angle C over the side of C. Well, in order to use this, if you notice, I need to figure out what angle C is. So if we fill this in, I know angle B is 31.4 degrees. I know side B is given as well as 5.1. I'm trying to figure out what side C is. I need to know what angle C is. Well, finding angle C isn't too bad. So angle C is equal to 180 degrees minus 31.4 degrees minus 39.9 degrees. So let's go ahead and see what that equals. Let's pop in our calculator. Okay, so we have 180 minus 31.4 degrees minus 39.9 degrees. And this is equal to 108.7. So 108.7 degrees. Now if you notice, I had 4 spots here. 3 of them I know now. I just have to solve, cross multiply, and divide to find for that 4th spot. So C sine 31.4 degrees is equal to 5.1 sine 108.7 degrees. So there's the cross multiply part. Now here's the divide part. Sine 31.4 degrees sine 31.4 degrees. So we have canceling occurring here. And then I know that angle C then is equal to 5.1 sine 108.7 degrees over the sine of 31.4 degrees. So let's go ahead and plug this into the calculator and solve. So 5.1 sine 108.7 divided by sine 31.4. So that's equal to the 9.2719, etc. A lot of these in the instructions, they'll say don't round till the end. So make sure you remember that advice, because if you round too soon, That's going to throw a lot of your answers off. So let's see what we get here. So I have 9.2719445, and let's round to tenths here. This would be 9.3, and I think we're working in kilometers, so 9.3 kilometers is how far the ship has traveled from the first reading to the second reading. So getting the correct setup here, the correct triangle, is going to be really important. So make sure that you take some time to get the correct setup before you try and solve anything. Okay, next we talked about an area formula at the beginning. So we're going to look at a problem where we're using that area formula. So let's go ahead and pull one in. It says find the area of triangle ABC. And what they show us here is we have two sides and an angle. Well, let's see what this setup looks like. So again, I'm not going to really worry about the proportion of this triangle, meaning which one is the obtuse angle here, etc. I'm going to go ahead and label this side A, opposite angle A, side B, opposite angle B, and side C, opposite angle C. So if we keep looking here, I know that A is 12.7, side B is 5.8, and angle C is 11.9 degrees. So what we have here then is a side, angle, side. Now I'm not trying to solve for this in terms of all the other sides, I'm trying to find the area. But what we have here then is we have finding the area given two sides in the enclosed or included angle. So area equals 1/2 5.8 times 12.7 times the sine of the included angle, which is 11.9 degrees. Now keep in mind something, make sure that when you're using your calculator that you're in degree mode, and we certainly are here. So I have 0.5 times 5.8 times 12.7 times sine 11.9, and I'm in degree mode, so I get 7.594, etc. And then we'll round this to the nearest tenth. And remember, this is area. So area equals 7.594500148, nearest tenth, area equals 7.6, and I think we're meters squared. So this is area. Now just a quick look at this. Usually I just use 1/2 base times height, but if I wanted to find the base and the height here, I'd have to come down, draw this height, figure out what that height was, and then figure out the base as well and kind of work from there. So it's not really all that easy and straightforward to do with these. So again, I can use those area formulas if I'm given two sides in the included angle. Make sure your calculator's in the correct mode. Make sure that you're looking at the rounding instructions, and be really careful when you're working through these to always use the given data instead of going off the data that you calculated in case you have any mistakes. As usual, if you have any questions, let me know, and we'll also be looking at law of sines, and our next lecture will be law of cosines.